All right, Precalculus students, welcome to your first official lecture. This is in our first real module, so Module 1, and this is Lesson 1.1, Operations with Polynomials. So in a second, I'm going to switch my camera to our notes page. All notes pages can be found on Google Classroom, so be sure you join that Google Classroom. And you can either print those notes out and follow along, or you can take notes on your own piece of paper, pausing the video as you need to, etc. At the top of our daily notes, I normally write our objectives for the day. It's really important to know what we're doing and to understand what we're doing before we actually do it. It just helps ground us kind of throughout the lecture so we can kind of remember, oh yeah, this is why we are doing that. So if you have any questions as you are watching this lecture, be sure to mark them down and we can answer them in our Zoom call. Also, once you finish the lecture, make sure you complete the CheckFor Understanding quiz. That just makes sure that you actually watch the lecture. All right, let's get started. All right, so as you can see, we have our objectives at the top of our notes. If you would like this template to use as we're taking notes, it is on Google Classroom. And I always upload my completed notes, but I would recommend you follow along either on your own piece of paper or if you can print this off, great, or use an app to fill this in as we're going through it. So first off, here are our two main objectives today. We're going to define the 5 key functions of Algebra 2. And then we are going to add, subtract, multiply, evaluate, and compose one type of function called a polynomial. All right. So let's go ahead and start with reminding you of the big 5 functions of Algebra 2. You might remember these, you might not, but we will be working with these functions throughout the year. So first off, polynomials. Polynomials are functions that look like this. So I'll give you an example. Let's say I have a function f of x, and it is 5x to the 4th plus 3x squared plus 2x. Barely fit it in. So that is an example of a polynomial. It's basically just a string of a bunch of variables and coefficients. Another example of a polynomial is like 3x plus 1. That's a really easy one. You might remember from Algebra 1, that's called slope-intercept form, and it is actually a polynomial. Okay, so a rational function, our next one, looks like this. So rational, the root word of that is ratio, which means fraction. That kind of helps me remember what rational functions look like. Here's an example. F of x equals 3x squared plus 2 over or divided by 9x plus 1. So this is an example of a rational function that is just 2 polynomials divided, right? So 2 polynomials divided. That is all a rational function is. Okay, so moving on to exponentials. Here's an example of an exponential function. F of x equals 3 to the x. Excuse how messy that is. Sorry about that. So 3 to the x is a little bit different. That's different than 3x, right? Because 3 to the x has a variable as an exponent. Variable as an exponent. That's what makes these unique. The next one is a logarithm. I fully expect no one remembers what a logarithm is. A logarithm looks like this. Let's say g of x equals log base 2 of x. We are going to talk about these at a later date. Don't freak out about logarithms yet. And the last big function of Algebra 2 is called a radical. And you might remember a radical looks like f of x equals maybe the cube root of x. Now we can write that a little bit differently. So we could write that as, instead of cube root of x, we can write it as x to the 1/3. Again, we're going to kind of weave back in a few class periods to talk about those. Okay, so let's go ahead and move on to kind of our next objectives. Now that you kind of know the big 5 functions we're going to be working with, let's actually start working with one of them called polynomials. So where we're going to start today is adding and subtracting. So our steps to add and subtract polynomials are to first identify like terms, combine like terms by adding or subtracting the coefficients, and then be sure to distribute any negatives. So I'm going to kind of go through those and make sure we know what those means, or what each of those things means. So like terms, remember that like terms have the same variable and exponent. Okay, so anytime we have the same variable and the same exponent, that is a like term. Another word I want to define before we move on is coefficient. So coefficient is just the numbers in front of variables. And that is what we are actually adding and subtracting. Okay, so let's look at some examples. So I have a polynomial here, right? Plus a polynomial here. And in order to add them, I just need to look at all the like terms and add their coefficients. So first off, the 3x cubed plus the 7x cubed gives me 10x cubed. Then I'm going to move on to this 5x to the 5th and look for any other x to the 5th. I have one, and it's subtracted. So 5x to the 5th minus 3x to the 5th gives me plus 2x to the 5th. And finally, I have a minus 2x or a negative 2x plus a 2x. Well, that cancels out to give me plus 0x. Now, that's kind of funny because 0x in math is just 0. And so our final answer here is going to be 10x cubed plus 2x to the 5th. Boom, done. All right, next one. So this next one, we are taking this polynomial and subtracting another polynomial. And what I want to do first here is distribute the negative. What that means is I'm going to take this negative here, and I will distribute it to each piece inside of that parentheses. Don't forget to do this. So I'm going to rewrite this first as 9x to the 7th minus 1. When I distribute that negative, I'm going to have minus 5x squared plus, remember, a negative and a negative cancels out. So I get plus 3x to the 7th. Now, I can remove parentheses when I'm adding or subtracting as long as I distribute any minuses or negatives. Okay, so let's keep going. So at this point, you're not done yet because we still have to combine like terms. So let's do that. We have 9x to the 7th plus 3x to the 7th, which is 12x to the 7th. I don't have any other constants here, so I just have minus 1. And I don't have any x squareds, so I just have minus 5x squareds. So that is one way to write this answer, but the standard form way to write this answer, you might remember that standard form is the following. 12x to the 7th minus 5x squared minus 1. And that is the proper way to write our answers. I didn't do it over here, and I'm normally not going to take points off for it, but just know that that's the standard form. All right, so next page of notes. We are going to, and I'm actually going to get another page so my pen doesn't bleed through. We're going to move on to multiplying polynomials, okay? So when we multiply polynomials, we multiply the coefficients and add the exponents. Be sure to multiply all pieces. So if there's some pieces that you have not yet multiplied, be sure to multiply them. All right, so let's knock out this first one. Just like that negative we saw in the last example, we have to first distribute the 3x cubed. Okay, so this is an example of distributing. So when we distribute, we're going to multiply everything inside the parentheses by everything outside of the parentheses. So 3x cubed times 9x. Remember, multiply the coefficients, 3 times 9, and then add the exponent of 3. And anytime there's not an exponent showing, it's an exponent of 1. 3 plus 1 is 4. And then 3x cubed times 1 is 3x cubed. That is in standard form, so we are done. Okay, so the next example is one where you have to do a different process. You can't, even though you are technically distributing, we call it foiling. So you might remember that word, FOIL. It stands for first, outer, inner, last. So we're starting with the outer piece here, the x, and we're going to distribute that first. And then we are going to do the same thing, but with this 1. And that is the foiling process. So let's go ahead and do that. X times x is x squared, right? I'm adding the exponents, 1 plus 1. X times this minus 2 is minus 2x. 1 times x is plus 1x. And then 1 times that minus 2 is minus 2. Now we are not done here. I hope you see why. We still have some like terms we can combine. That is always normally the last step. So we have x squared. Negative 2 plus 1 is negative 1. So I'm just going to write negative x, then minus 2. All right, so as we're going through this, I'm just going to remind you, if you have any questions or anything like that, you can write them down and then ask me during our Zoom call. If I do something wrong, and trust me, I always have my whiteout near me because I make a lot of mistakes. So if you catch a mistake, you can bring it up in our Zoom call as well. All right, so let's keep moving on. So this one, example 5, is a little bit different, right? Because instead of just having 2 terms and 2 terms, I'm actually adding on a 3rd term here. Well, guess what? Foiling kind of applies to this problem as well. We are going to distribute every piece of this first one to every piece of the second one. All right, so this is what that looks like. So first, I'm going to take the 3x squared and distribute it to everything inside there. Then I'm going to take that minus 6x, and I'm going to distribute that to everything in there. And then last but not least, that 1, I will distribute to everything as well. Okay, so that is the process to multiply this. Let's go ahead and do that. 3x squared times x is 3x cubed. 3x squared times 2, it gives me a plus 6x squared. Now let's move on to that next piece. So negative 6x times x is minus 6x squared. Negative 6x times 2 gives me a minus 12x. And I'm running out of space pretty quickly. 1 times x is plus x. 1 times 2 is plus 2. Barely got it in. Again, last step here is to combine like terms. Well, this is a unique example because, check it out, those 6x squareds cancel each other out. One's positive, one's negative. So my final answer is going to be 3x cubed. The negative 12x plus x gives me a negative or a minus 11x, and then plus 2. Golden. Okay, so the very last example, I'm actually going to bring this one up in our Zoom call. I want you to try it yourself. It's a little bit tricky, and it uses what we call the order of operations. But we will look at that on our Zoom call. Okay, so the next thing we're going to do is evaluate some polynomials. So we've added, subtracted, and multiplied, so now let's evaluate. When we evaluate, all we're doing is plugging things in. What I mean by that is we're replacing the x's with other things. Let's see how that works. So I give you 2 functions, right? I give you f of x and I give you g of x, so 2 different functions. In this first example, I ask that you evaluate f of 2. So here I'm going to take this 2, and instead of it being f of x, I'm going to plug in 2 wherever there's an x. This is what that looks like. F of 2 equals 2. I always use parentheses when I'm plugging in. 2 squared plus 1. Well, I know what 2 squared is. That's 4. Plus 1 gives me 5. And that is our answer. So normally when we evaluate with numbers, we wind up with a number. Let's look at another one. So on this one, I'm using g now, right? G is this function up here. And I'm going to plug in negative 2. Well, g of negative 2 is equal to 3 times negative 2. I'm just replacing all the x's with negative 2. Minus 4 times negative 2 squared plus 1. I never want you to leave your answers like this, right? I want you to be able to simplify this. So if I simplified this, I would get negative 6. minus 4 times, well, negative 2 squared is positive 4 plus 1. Okay, so let's keep going. We're not done yet. So that is going to give me negative 6 minus 16 plus 1. If I fully simplified that and combined all those, I'm going to get, let's see, negative 22 plus 1 is negative 21. And that is my answer. All right, so let's move on to a weird example, right? Rather than just plugging in numbers, we can plug in polynomials. We can plug in expressions, right? So check this out. F of x minus 1. I'm going to take all of the x's in f of x and replace it with x minus 1. That's pretty crazy. Let's see how that works. So f of x minus 1 will equal x minus 1 squared plus 1. I replaced that x with this entire thing, x minus 1. Well, we could leave our answer like that. That's okay. But it's better if we can multiply that out and simplify it. So let's do that. X minus 1 squared is equal to x minus 1 times x minus 1 plus 1, right? Anytime I square something, it just means I'm multiplying it by itself. And now I can FOIL this. If I FOIL that, this is good practice for you. I'm going to do it a little bit quickly. So x squared minus x plus 1. And I'm going to drop down that plus 1. So this process was the FOILing step. And now let's combine like terms. X squared minus 2x plus 2. There's our final answer. All right, so the last one, we are going to take 2x and plug it into our g of x. So g of 2x is equal to 3 times 2x minus 4 times 2x squared plus 1. Took the x's and replaced them with 2x. Well, when I do that, I'm going to get 6x minus, so be careful here. I do want you to always show your work because you can kind of get into a trap here. 2x times 2x is 4x squared, right? So just this little bit here, the 2x and then the squared became 4x squared, and I still have a plus 1 on at the end. Our final simplification is 6x minus 16x squared plus 1. Now that is not in standard form because I didn't line up the exponents, but that's okay. All right, so that is evaluating polynomials. We are going to do a couple more examples in this function notation, right? So we're working now with things defined with functions. And luckily on examples 11 and 12, we're actually going to be using the same function. So I will put them up down below so I don't have to switch back and forth. So on example 11, still using f of x and g of x, and the first one I'm doing is subtracting. Okay, so f of x minus g of x. Well, when I do that, we know how to subtract polynomials, and this is just polynomial math. So let's go ahead and set it up. This is going to be equal to my f of x, which is x squared plus 1. And now I'm going to subtract g of x, and I always like to put it in parentheses because I'm going to have to distribute that negative. So let's make sure we follow. F of x, this here, is right there. And then the g of x is in parentheses, right? That is right there. Okay, so we know how to do this. Hopefully, this looks familiar because we did one earlier. We're going to first distribute the negative. So minus 3x plus 4x squared minus 1. And now we can simplify. So we will combine like terms, 5x squared minus 3x, and it looks like those ones are going to cancel. All right, so we have one more evaluating example. We are going to evaluate g of 1 times f of 2x. So this is kind of by far the weirdest one that we've done yet, but it is not too bad. So let's go ahead and do it. So first off, let's do that guy there, g of 1. Well, I'm going to plug 1 into g, so that looks like this. 3 times 1 minus 4 times 1 squared plus 1. And now, just to make it clear, I'm going to be multiplying that by f of 2x. So I'm going to plug in 2x to f. So I get, let's see, 2x squared plus 1. And I'm going to use parentheses here since I am multiplying. So I kind of want to back up and take a kind of higher level view of this. Keep in mind that this is going to be a number multiplied by something that is going to have variables in it, right? So if I simplify this, I get 3 minus 4 plus 1, which is, let's see, negative 1 plus 1, which is 0, right? So I'm taking this kind of piece by piece. Now, over on this side of things, I'm going to have 4x squared plus 1. So down below, I'm sorry this is a little bit confusing, but I'm going to have 0 times 4x squared plus 1. Now, this is kind of funny because 0 times anything is 0, so my answer is 0. All right, so our very last topic of discussion is going to be composing polynomials. When we compose polynomials, what that means is we are plugging one function into another function. Okay, so here is what compositions or composing looks like. I'm plugging in g of x into f of x. So normally I don't simplify these all that much, and I don't expect you to all the time. There are certain exceptions that I'll comment when we get to them. But here is what I'm going to do. I'm going to take g of x, this incredibly, well, not incredibly, but a relatively complex thing, and I'm going to plug it into x there. All right, this is what it looks like. F of g of x equals, take this guy, plug it into that x. So I'm going to have 3x minus 4x squared plus 1 squared plus 1. And I'm going to go ahead and let you leave it like that. That would take a while to multiply out. All right, next one. So this is another way to compose functions. It's we read this as g of f of x. So it basically is the same thing as this one, but switched. This is f of g of x. This is g of f of x. Just different notation. So when I evaluate this, I'm going to do the opposite. I'm going to plug in f of x into g of x. So g of f of x will be equal to, oh, this is going to get ugly really quick, Moon. You should have made more room in these notes. Okay, so let's go ahead and do it. We are going to have 3 times x squared plus 1 minus 4 times x squared plus 1 squared plus 1. All right, so hopefully that makes sense. We just took that and plugged it in. On a test or something, I would expect you to know how to simplify this, and we might even do it during our Zoom call, but I'm going to leave it there for now. Okay, so moving on, some weirder ones. So here, I'm asking you to find f of g of negative 2. Well, f of g of negative 2 is basically plugging in g of negative 2 into f. So I'm going to remind you, g of negative 2 equals, I think we evaluated this in one of our last examples. So you can see in example 8, we saw that g of negative 2 is negative 21. So since g of negative 2 is negative 21, that's from example 8, I just need to plug in negative 21 into f. All right, so let's do that. F of negative 21 is equal to negative 21 squared plus 1. Now, I would expect you to be able to then multiply that out. And what we are going to get is, remember when we square a negative, we get a positive. So I'm going to get 441 plus 1, which is 442. All right, our very last example today, I hope I'm doing well on time. We are going to do something crazy. We are going to compose f into g and then compose that entire thing back into f. So this is a really ugly problem. I'm going to get started. I'm going to let you try to finish on your own, and then we'll talk about it in Zoom. So here we go. I know that g of f of x is this guy here, right? So make sure you make that connection. So I already have that there. So since I know that, I just need to plug this entire thing into f of x. All right, that's going to be disgusting, but let's try it. So that is going to be equal to 3 times x plus 1, I'm sorry, x squared plus 1 minus 4 times x squared plus 1 squared plus 1. Now remember, all of that is being squared because I'm plugging it into f of x, which is a squared variable. And then I have a plus 1 on at the end. All right, so that is something that will take forever to simplify, so I'm not going to do it now. If you have questions about that in Zoom, of course you can ask. So that's all there is today. Make sure to check out our Check for Understanding quiz and our assignment. And then make sure to join our Zoom call so we can discuss and talk about this a little bit more. Have a wonderful day.